Hey, Nathan here. Welcome back to another DirectX video. It's been a while since I've done a DirectX video with the website in development for the past several months. That's been taking my main focus. But like I mentioned on the Introduction to Monogame video, that I'm back to making videos and I'm recording a lot of them in bulk. So I have about 6 tutorials made and this will be the 7th one, and I plan to finish the DirectX series. Now this is Sunday, May 31st. I plan to record this and also release this right away. And I will work on the next one if I have time and release that right away today. So you'll have 2 today if I get time. Definitely this one. The next one's going to be a pretty short video, so I think I will have time to get to that. So last video, I showed you how to get the keyboard state, and we use a function called GetAsyncKeyState, and we pass in the V key, the virtual key value, to retrieve. Now in this video, I'm going to show you how to move a sprite by using the GetAsyncKeyState. Now this video, I'm going to use the updating sprites with timers sample. I'm going to use that for a base and then extend on that. So I will provide that zip file down below in the description or on my site, and then you can download that. It's tutorial 8, so I'll label that download tutorial 8 sample. So you can download that, extract that, and open that up, and then follow me here. Now, I mentioned in the previous series, the new series that are starting, and the previous videos that I've made, but this is the DirectX series, and I haven't made a video on that just yet. I'm now using Visual Studio 2013, so from this video on, the solutions, the project samples will be in Visual Studio 2013. You can download that and then use the CPP and H files, and then add it to the 2012 or whatever version you're using. You can just use the source files and use that way. But the solution files will be in 2013. And Windows 10 and Visual Studio 2015 are right around the corner. When they are released, I'm going to update to that right away. So when 2015 is officially out, everything from that point on will be 2015. So just wanted to give you a heads up that if you're downloading this and it's not working, if you have an older Visual Studio, that's probably what the issue is. Okay, so this is the tutorial 8. This is the updated sprites with timer sample. So this is the completed sample. I'm just going to use this as a base. You know, I'm not touching the keyboard or anything. It's just updating itself. So let's go ahead and rename the window, and let's call it Sprite Movement. And I'm going to change that to Sprite Movement Sample. Alright, now if we go to game.cpp, I'm going to, actually let's go to game.h. I'm going to remove one of the players. I only want to move one player, and I only want one player to be on the screen. So I'm going to remove one of the game sprites here, which means I'm going to have to go to game.cpp and remove it from the initialize function here. Anytime we have player 2, we need to remove that. So if we have if player 2 here, player 2.update, let's remove that. And in the draw function, we have if player 2, and it is initialized, so let's delete that. And in the destructor, let's delete the player 2 line there. Alright, so now if we press F5 and run that, now we have only one player. Now we do not want that to automatically update, so we're going to have to change that. So let's delete the velocity lines here. That is in the initialize function in the game.cpp file. Just delete where we set the velocity. And the reason for that is we want to update the game by our keyboard input. We do not want it to automatically update. Now if we go to the player.update here, let's go to definition. And so we're going to the GameSprite.cpp file and the update function here. And this is fine. We will set the velocity based on our input, so this is fine. And everything else looks fine, so we're good to go. I'm just going to go ahead and hit save all. Alright, so now a couple things we need to do is on the game sprite, we need to add a function. So let's go to GameSprite.h here. And as you see, we have virtual void update and virtual void draw here. Let's add one for virtual void, and that's going to be handle input. Alright, so virtual void handle input. So the game sprite is going to have its own handle input function, and then we can, depending on if it's a spaceship or if it's some other entity, they might move differently. So you want to have each game sprite to have its own handle input procedures. Now if we go to the game sprite.cpp file here, we need to actually provide the code for that. So that is going to be void game sprite : handle input. And we don't have any parameters or arguments or anything, so we can just do that. Now, I mentioned that we are going to use the velocity here. But we need to calculate a movement vector based on what we have pressed. So if we move up, we want to have a movement vector pointing up. If we press the down arrow, we want to have a movement vector pointing down. And similar with the left and the right. So I'm going to use the D3 DX vector 3 here. And I'm going to call that the movement vector. Let me move my mouse here. So that's going to be a movement vector, and initially we're not going to move at all. So 0, 0, 0. So we're not going to move at all. And I'm using the vector 3 because the game sprite position is based off of vector 3. In the advanced training series, we will create our own vector and have some stuff that way. That we don't have to use the D3DX vector for that stuff. Alright, so now here is where we can get our input and start manipulating this movement vector. Now this movement vector is only going to be used to manipulate the velocity. This is just to determine what direction we are moving. So just like last tutorial, if GetAsyncKeyState, and then we open parentheses, now we need to pass it the virtual key. So I'm going to use the arrow keys, up, down, left, right. So VK underscore up. That's the up arrow key. So if we press the up arrow key, we want to set the movement vector.y. We are moving up, which is negative y. So that needs to be minus equals 1. We start at 0 in the y. When we move up, it's going to subtract 1 from that. We need to do the same thing for the down arrow key. If GetAsyncKeyState VK underscore down. So that is the down arrow key, so we need to set the movement vector.y plus equals 1. Moving down is positive y. So that is the y direction, up and down. So now we need to do the x direction, left and right. If GetAsyncKeyState VK underscore left, that is the left arrow key, movement vector.x minus equals 1. Moving to the left is negative x, so we subtract 1 from the x value. Now we need to do the same thing for the right arrow key. If GetAsyncKeyState vk underscore right, that is the right arrow key, movement vector dot x plus equals 1. We're moving to the positive x direction, so we add 1 to the x component of the movement vector. Now there's a lot of ways that we can do this. You don't have to use a movement vector. You can do this in a lot of ways. This approach for this tutorial, I'm choosing to test to see if movement vector, if any of the components are not 0, that means we are moving. If the movement vector is not 0, we can move. So I'm going to test each component, movement vector.x. So if movement vector.x does not equal to 0, or movement vector.y does not equal to 0, that means we are moving in some direction, either x or y, or both. If we hold the up and right arrow, we're moving negative y and positive x. So this tests to see if we are moving. If the movement vector is not 0, we need to calculate the angle that we're moving. Remember, this is just used to determine where we are moving, what direction we are moving. We are doing it this way to calculate the, it's basically controlling how to manipulate the velocity. Like I said, you can do this numerous ways. We can directly manipulate the velocity if you want to. You don't have to deal with a movement vector here. But it's a good idea to deal with the movement vector. That way, if there's some issue with your mathematics converting from a movement vector to manipulating the velocity, you can deal with it that way. You can make sure that the movement vector is indeed correct, and it's just the manipulating of the velocity that's not correct. So we're going to get a float angle here, and we are going to use atan 2. Now there's a lot of reasons why we are using this. Coming up, I'm going to release a game math series, and I'm going to, for the first episode, I'm going to talk about the vector operations and what you need to use to get certain properties of vectors. You know, a vector has a magnitude and a direction. So it has an angle and a magnitude, or what we will use it for as speed. We want our game object to travel at this direction at the speed. So we have those two values. For here, we have our x component and y component of our vector. We need to get the angle. And one of the functions that we use to do that is the inverse tangent. And we do that by calculating y divided by x. Now in DirectX and XNA and Monogame, we use atan 2 to do this. So the reason we use atan 2 is because that operates in all 4 quadrants. And the normal atan only operates in 2 quadrants. I think only 1 and 4. But in the coordinate system, that's a box, not a pen. You know, we have the standard coordinate systems, and these are quadrants here. So the atan 2 operates in all 4 quadrants. So that's why we use atan 2 for this. Now, to get the angle of something, we have the x and y components. We take the inverse tangent or arctangent of y divided by x. But we have the atan 2 here as a function, and we need to pass y and x as arguments. So movement vector dot y, comma, movement vector dot x. So that will give us the angle. Now we need to use the speed of our object. So the speed of our object is the a float representation on how fast we want our object to travel. No matter what direction the object will travel, we want to have it go at the same speed. Now I'm going to go to the GameSprite.h here, and I'm going to go to the private section of the class, and I'm going to add a float for speed. Now I'm going to go back into the GameSprite.cpp file, and I'm going to go into the initialize. Actually, I'm going to go into the basic constructor here, and I'm going to set the speed is equal to 0. Now we have another constructor here that accepts an x and y, and that's for position. I'm going to extend on that by having a float for speed. So I'm going to go back to the GameSprite.h here, go into this constructor, and I'm going to add a float s. I'm going to add that here. Now I'm going to go back to the GameSprite.cpp, and I'm going to add that to the implementation here. Float s. So right after we set the color, let's set the speed is equal to s here. Alright, so now our GameSprite now has a speed component, and we can actually use our movement vector's angle with our speed to get the appropriate velocity. So don't worry about the math side. If you are interested in the math side, go and check out my new series coming out. It'll be for game math, for just covering any concepts we run into for game development. So it won't go into heavy calculus mathematics. It's just going to be focused for game developers. So that series is going to be called Game Math, and I'm going to start that. I worked on the first 2 episodes. I will probably release the introduction along with this and probably the next DirectX video. So hopefully there will be 3 videos out today. Alright, so back into the GameSprite.cpp file, we can actually use this angle and use the speed we just created and use that to create our velocity vector. So velocity.x is going to be equal to the speed value times cosine angle. Velocity.y is equal to speed times sine of the angle. So that we're getting the x and y component of our velocity, and we're doing that by using the trigonometry functions cosine and sine. And we're multiplying that by the speed because that's how fast we want the object to travel. Now, if we do not move, we need to set the velocity.x is equal to 0, velocity.y is equal to 0. Alright, so let's go to the game.cpp here, and where we update our player, we need to handle the player's input. As you saw at the first few minutes of the video, we created a handle input function in the game sprite. And if we go to game.cpp, player here is a game sprite. So each game sprite needs to handle its own input. So I'm going to add curly brackets here since it's going to be multiple lines. And I'm going to put player, and then we need to provide an arrow here, handle input. So player's going to handle the input, and then it will update. So if we save it and press F5, we have a build error. And as you see here, we forgot to take care of the constructor. So let's set our speed to, what's a good amount? We're doing this based on game time. And that's the appropriate way to take care of this. Some games use the position plus velocity. They do not include the game time. And that is not the right way to do that. If you have a game that operates at 60 FPS and then it jumps to 500 FPS, all of a sudden all of your objects are going to move really fast. You do not want that to happen. You want to use the game time. That way, no matter what the FPS is, the object will travel at the same speed on the screen. So whatever we set in the constructor here, think of it as pixels per second. How far you want the object to travel per second. If you do not have game time here, you'll need to think of it as pixels per game loop. So I'm going to set it to about 300. So our object is going to travel 300 pixels for every second. If we hold down the right arrow key and we hold it down for 1 second, our object will have traveled 300 pixels. So now if we save it and press F5, it should be good. Up, down, left, right. So now we have our keyboard input tied to our game object. And the faster we want it to move, we just increase the amount of speed that object has. So now it moves faster than it did before. The slower we want it to move, we decrease it to a very small speed value, and now it moves really slow. But since we're using game time, think of this as pixels per second. So be sure to use game time in your update logic. It doesn't matter if somebody has a really fast computer and they can achieve 500 frames per second or more. You want everything to be at the same speed. And a lot of tutorials will have we'll set the velocity to 2.5 or something like that. They'll set the speed to that amount, and that's because they're using 2.5 per game loop. So I'm going to take this out temporarily and show you. So I set it to 2.5, and it's going about the same speed as about 100 or 150 or so. That's per game loop. If I put the game time back in there, that's going to be 2.5 per second, which is going to be very slow. I'm holding down my right arrow key and it doesn't look like it's moving. I'm going to set my pointer here. I'm holding down my right arrow key and you see it slowly moving. So keep that in mind. Pick whichever one you want to go with. If you pick the per second approach, you need to have your speed at a much higher value. So that's it for this tutorial. I hope you enjoyed it. Next tutorial, we will discuss drawing text to the screen, and there's two approaches for that. I'll discuss the first approach. And then that will be it for the basic training series. After that, we're going to break the DirectX series as a whole into two parts. We're going to work on the paddles, our pawn clone for DirectX. We're going to build a paddles clone or pawn clone. We're going to call it paddles. That will be one tutorial series. That will be a few episodes. The other series will be the advanced techniques, where we will build an input system and we'll do a few more things. So I hope you enjoyed the series. Stay tuned for the next episode, the final episode of the series. And I hope you enjoyed this tutorial and learned how to tie in keyboard input to your game sprite. See you next time.